Question 9. A light elastic cord with force constant 25 newtons per meter is fixed at its upper end to a support. A 0.40 kilogram object is gently attached to the lower end and released from rest. Air resistance is negligible. Determine the maximum extension of the cord. This problem tests our understanding of energy conservation in elastic systems. Let's set the stage with the right ideas. We know that for a spring or elastic cord, the elastic potential energy stored is given by E elastic equals 1/2 kx squared, where k is the spring constant and x is the extension. The gravitational potential energy change is given by delta E grav equals mg delta h, where m is the mass, g is the acceleration due to gravity, and delta h is the vertical displacement. In the absence of air resistance, mechanical energy is conserved. This means the sum of gravitational potential energy and elastic potential energy is constant. If we are familiar with these ideas, we can begin to solve the problem. We are given the mass to be 0.40 kilograms. The spring constant for the spring is 25 newtons per meter, and the acceleration due to gravity has the value 9.8 meters per second squared. We can apply the principle of conservation of mechanical energy. Initially, when the object is released from rest, all of the energy is gravitational potential energy. So we have E grav equals mg x max, where x max is the maximum extension. At the maximum extension, the gravitational potential energy is completely converted into elastic potential energy. Therefore, the elastic potential energy is E elastic equals 1/2 kx max squared. Now, applying conservation of energy, we equate the gravitational potential energy and elastic potential energy. mgx max equals 1/2 kx max squared. Next, we simplify the equation to solve for x max. Dividing both sides by x max, we get mg equals 1/2 kx max. Solving for x max, we find x max equals 2 mg over k. Substituting the given values, x max equals 2 times 0.40 times 9.8 over 25, which simplifies to x max equals 0.3136 meters, or 31.4 centimeters. This is our final answer. What did we do? We wanted to determine the maximum extension of the cord. We used the principle of conservation of mechanical energy, where the gravitational potential energy at the start equals the elastic potential energy at maximum extension. We solved for the extension and obtained the final value. Job done, and we can summarize to conclude. We have seen that the maximum extension occurs when all of the gravitational potential energy is converted into elastic potential energy. Using F equals kx directly ignores the gravitational potential energy gained during the fall and underestimates the extension. This is because at the equilibrium point, where the restoring force equals the weight, which would have been about 0.157 meters, the net force is 0, but the velocity is maximum, not 0. So the mass continues downward. This makes this extension not the maximum possible, as the mass continues downward. The energy conservation principle dominates in determining maximum extension, not instantaneous forces.